A rectangular channel has a width of 2 meters and carries a discharge of 5 meter cube per second with a depth of 1.70 meters. A smooth hump of 60 centimeters height with flat top is located at a certain section. Calculate the likely change in the water surface. Neglect the energy losses. This is similar to the previous problem. The only change in this problem is the height of this hump. It is 60 centimeters. In the previous problem, it was 10 centimeters. We have to calculate the change in the water surface due to this hump of 60 centimeters height. Now, height of the hump is 0.60 meters. Width of the channel is 2 meters. Depth at the upstream section is 1.7 meters. Discharge is 5 meter cube per second. Area equal to B into Y. Uh, B is the width and Y is the depth. So we get the area equal to 3.4 meters square. Discharge per unit width is the total discharge Q5 divided by width of the channel, which is 2. So 5 divided by 2 is 2.5, and velocity is discharge divided by area, which is equal to 1.47 meters per second, and velocity head is v square 1.47 square divided by 2 into 9.81 meter per second square. So velocity head is 0.110 meters. Now this is the specific energy diagram. Specific energy at section 1 is equal to y1 plus v1 square by 2g. Okay, y1 is the depth, v square by 2g is the velocity head. At section 2, there will be some reduction in the specific energy. Okay, so E2 will be equal to E1 minus delta Z. Delta Z is the height of hump. Okay. Now let us calculate the change in the water surface. Now Froude number is 0.360. It was obtained using this equation. If Froude number is less than 1, the flow is subcritical. Okay. As the flow is subcritical, this hump will cause a drop in elevation. Okay. So it will cause a drop. Now specific energy at section 1 is equal to y1 plus v1 square by 2g. Now depth at upstream section is 1.7 v square by 2g. Velocity head we have already calculated, it is 0.110 meters. So 1.7 plus 0.110 is equal to 1.810 meters. Specific energy at section 2 will be equal to E1 minus delta Z. E1 is 1.810 minus zero point 0.6. So E2 is equal to 1.210 meters. Now critical depth, okay, this point C, it corresponds to minimum specific energy. Critical depth can be obtained using this equation, Q square divided by G raised to 1 by 3. This Q is the discharge per unit width. So critical depth is 0.860 meters for this rectangular channel carrying discharge of 5 meter cube per second. Now specific energy at critical depth can be obtained by multiplying critical depth with 1.5. So 0.860 multiplied by 1.5 will give us the specific energy at critical depth. So if we draw a line here passing through C, this line will represent specific energy at critical depth. It is equal to 1.291 meters. Now in this problem, E2, which is the specific energy at section 2, is less than the minimum specific energy. Now EC is the minimum specific energy. Now this cannot be possible. For a given flow, which is 5 meter cube per second in this case, there cannot be any value of specific energy less than EC. In this case, E2 is 1.210, which is less than EC, which is 1.291. So flow will not be possible. Depth at section 1 will change to make the flow possible. If minimum specific energy EC at section 2 is more than E2, okay, in this case it is more than E2 that we calculated, then upstream depth Y1 will change and E2 will be equal to EC. Okay, so minimum specific energy will be equal to E2. It cannot go on the left hand side. Okay, this is the minimum value. It cannot go further left. So EC, E2 will be equal to EC. If depth at section 1 does not change, we will use this calculation, but in this case, depth at section 1 changes. So if depth at section 1 changes, we will use solver to obtain the new depth at section 1. Specific energy at section 2 is equal to 1.291. Okay, because E2 is equal to EC. Okay, it will be the minimum specific energy. Specific energy at E1 at section 1 will be equal to 1.291 plus delta Z, right? E1 will be equal to E2 plus delta Z. Delta Z is the height of hump. So 1.291 plus 0.60 will give us the specific energy E1 dash. This is the new specific energy. Now we will use solver to obtain the value of the new depth. Now we already know specific energy at section 1. It is 1.891. Now let us use solver. Now value of this cell should be equal to 1.891. Okay, and I will change this cell. It shows the value of y1 dash new depth at section 1. Okay. So the new depth will be 1.792 and depth y2 is 0.860. Okay, so y1 will be 1.792 instead of 1.7, and then we'll get critical flow at section 2 and its depth will be equal to 0.860. Okay, so we have obtained new depth at section 1 and depth at section 2.